Hello guys, KTaNE here and welcome to Simon's Sums. This is what the module will look like. It'll be similar to stuff you've seen like Simon's Stores and stuff like that. And it works in a reminiscent way of it, but not entirely the same. This module is quite long-winded, as you can see here. But I'll try to explain it as best as I can. So, without further ado, let's just get started with it. So first of all, we need to figure out the initial button values. This is decided by where they are in this shape and another value which we'll get to here. Actually, right now. Take the first character of the serial number, convert it from base 86 to decimal. First character of the serial number is 2, from base 86 to decimal is 2. If you also like C, for example, that would be 9 plus 3, the 9 plus the alphabetic position of that letter. So that would end up being 12. So this is the value we're going to be, that's going to be our base number. And then using the direction of the colour and the colour itself, we're going to add a number to this, basically. So then we get our values for each colour. R, G, B, C, M, Y. So red is northwest. So we add 31, so 33 to the initial value we got. G is south, so we add 9, 11. B is northeast. Blue is northeast, so we get 7. Cyan is southwest, so we get 12. Magenta is southeast, so we get 17. 15 plus 2. And finally yellow is north, so we get 5. These are our initial values for the colours. And now we had to figure out the flash values. The flash values is based on how many times it flashes and some other stuff about the colours, specifically about the ones that are flashing. So in this case, cyan and magenta. So the initial cyan value is 12, and the initial for magenta is 17. So, starting with the first value here. So the initial value of the colour of the flash to make it your initial F, which would be our flash value. And then every time this colour flashed in the sequence -1, it only flashed once in this sequence, so we're going to add 0. If your adjacent buttons flashed in this stage, add 8. These two buttons are separated, so no. To take to that stage, no, we can ignore that. If this is not the first flash of the stage, we ignore that it is the first flash of the stage. If F is negative, no. So this is our current value. And do note, if the F value matches previous F value earlier in this stage, add 1 until it's unique. So you can't have the same flash value for two values in a stage. So then yellow, magenta, and then times it flashed, -1, just 0. Adjacent button flashed, no. The second, third stage, no. But this is not the first flash of a stage. So we're going to subtract 1 from F. The number buttons we need to go counterclockwise to get to the previous flash. So that'll be 1, 2, 3, 4. Subtracting 4, we get 13. Unless the previous one flash is the same as this one, in this case, add 13 instead. So, Next, we check if it's negative, it's not. And it does not match any of the previous values. So this is our final value for this one. So now we're going to determine button presses. We're on the first stage. So we're going to press the button with the lowest flash value, then the one with the highest. Quite simple. Cyan, magenta. So we're going to be pressing cyan, then magenta. And now we got to figure out when to press them. So in this case, to do this, to determine the press values, we take the sum of the flash values for the colour. So if a colour flashed more than once, you sum all of those values at the start of this. But since these all flashed once, we only use that value. And if the colour never flashed, because in later stages you might be pressing buttons that didn't flash, it's just the initial value. This is called X, so the current X value for both of these is 12 and 13, respectively. Actually, putting next to these leading, so 12 and 13. Divide X by the number obtained by from the table depending on the location of the flash. So, in this case, it's just, again, the location similar to in this table. So cyan and southwest. Cyan southwest is this, and magenta southeast is this value. So plugging this in, we get 8 and 11. Take this modulo 5, 3 and 1. This is referred to as Y. At the Y value of the previous stage and take modulo 5, this is the first stage, press of a stage, use the last press of the previous stage, or 0 with the first press of the first stage. So in this case, we're adding nothing to the first one, and adding 3. Okay, the previous press, the Y value of the previous press is 3, so we can add it to this one, so we get 4. I take it by 5, so it's still 4. And this is the final Y values. So hopefully we've done this right. We'll be pressing cyan when it'll go there. Sorry about that. We're going to be pressing cyan when the sum of the digits, of the seconds digits, modulo 5 is equal to our Y value. So when the sum modulo 5 is 3 and then 4. So let's see if we've done this right. So modulo 5 to get 3, we can do 8 or 3 or 13. Let's go for 3 just to be safe. And then magenta on 4, which would be 4 or 9. We can go 4 again. We move on to the next stage because we got the right answer. Sorry for that mini pause in the middle of that. And also just keeping the hold on of everything because it's useful on the last stage. So up next we have blue, blue, blue. It's an interesting one. So initial values 777. Start with the initial value of the colour F flashed and make it your initial F. Add the number of times this colour flashed in the sequence -1. So 9, 9, 9. Because that's 3 minus 1, 2. So adding 2 to 7, we get 9. If an adjacent button flashed in this stage, add 8 to F. No, it didn't. It's only blue. If this is the second, third stage, this is the second stage. And this colour didn't flash in the previous stage, which is true. We had time magenta last time. Subtract 15. So subtracting 15 from all of these. we get -6, -6, -6, -6, -6. This is not the first flash on the stage. Subtract 1 with for the number of buttons you need to go counterclockwise, get a button on the previous flash. Unless the previous button is the same as this one, when in this case you add 30 instead. So this one stays the same. This one becomes plus 30. So 24. And this one is the same, so 24. So if everything's negative, take the absolute value. And then if this F value matches the previous F value earlier in this stage, add 1 to its unique. So this will have 25. So these are our F values. In this case, we have blue, blue, blue. But the colours we're going to be pressing instead is we're going to first take the lowest flash value, which is this one. Start on blue. Press button these 2 clicks from the lowest flash value, so green. Then the button is diametrically opposite the button with the second highest flash value, cyan. And then the button with the complementary code to the button, or the button with the highest, go to blue. If you know RGB arithmetic, the combination code is just present becomes absent, absent becomes present, so it's going to be RG blank, which is yellow. And now determining when to press the values. Same again, blue. Oh, actually, take the sum of the flash value. We only use the colours here specifically. So, to do this, take the sum of the flash values for the colour of that stage. If the colour never flashed, in this case, none of these actually flashed, we're going to be using their initial values, so 11, 12, 5. Ideates by the number obtained from the table depending on the location of the flash and round down. But in this case, it is just the location of that colour, I think. I might end up getting this wrong. So, it's going to be this. Here we have cyan. Cyan and southwest. And yellow, north. We get 782. Taking these mod 5, we get 2, 3, 2. And adding the Y value from the previous stage. So we get 6, which mod 5 becomes 1, this becomes 4, this becomes 6, becomes 1. So hopefully this is going to be G1, C4, Y1. So this we can go for that, then that was at 6 or 1 in mod 5, 9 of 4, and 9 of 4. No, 9 of 4, 1 or 6. And there we go. So remember these values. Just a reminder, when it says location of the flash, it means the button, not the flashes. So, third stage. Okay. Starts off exactly the same as previously. We have red, cyan, yellow, blue. Cyan, yellow, blue. Which becomes 33, 12, 5, 7. And then we do the same process again for these ones to begin with. So, at the number times this colour flash in the sequence -1. All of these again this time are. All of these are, in fact, once again. So we're adding nothing to all of them. If an adjacent button flashed in this stage, add 8 to F. That is true for all of them this time. Every single one has at least one adjacent button flashing. So we're going to add 8 to all of these. So 33 plus 8, 12 plus 8, 5 plus 8, 7 plus 8. Get this. This is the second, third stage. It's the third stage. And this colour didn't flash in the previous stage. Subtract 15. So we're going to be subtracting 15 from the first 3, but not the last one. Subtract 15 from all of them, part of the last one. Because blue did actually flash in the previous stage. Which then gives us that. This is not the first flash on the stage, so not including this one. So taking this. This is not the first flash on the stage. Subtract 1 from F for the number buttons going counterclockwise to get to the previous flash. So for the second one, go counterclockwise to get to the first flash. It's 1, 2, 3, 4, 5. So we subtract 5, so 0. For the second one, to get to the previous flash, we need to go counterclockwise 2. And this one we're going to go counterclockwise 1. Yeah, so 14. That is subtracting 1 for each of the counterclockwise movements to get to the previous flash. None of them were the same, so we now have 30 this time. If it's negative, take the absolute value. That only applies to this one. And none of them match this time. So, these are the values we're going for. In the third stage, the first 3 presses are similar to the first stages, but the last press is the most complicated one. Similar to something like Bamboozled Again, if you've seen that. So, start with the 4th highest flash, or the lowest. This one. Just to note down. Red, cyan, yellow, blue. Start with the 4th highest flash, and go clockwise until you hit red, green, or blue. So, the lowest is cyan. Going clockwise till we hit red, green, blue, we hit red. So the first press is red. 3rd highest flash, go counterclockwise until we hit cyan, magenta, or yellow. So the 3rd highest flash, going from yellow, going counterclockwise until we hit cyan, magenta, or yellow. We get cyan. Cyan went that way, and then yellow went that way. The 3rd press, use the button with the complementary code of the button diametrically opposite the button with the 2nd highest flash. So the 2nd highest flash is blue, diametrically opposite that is cyan. So the complementary colour of the button diametrically opposite the button with the 2nd highest flash would be the complementary colour of cyan, because it's diametrically opposite blue, and that is a combination of green and blue, so the combination code is red. And then we had to figure out the last press. We'll figure out the last press in a second. Let's do the first three here. So, taking the flash values, so that's 26, 0, and 26. None of these weren't flashes this time, so we have values for them. Divide this by the value we get from here, so red and northwest is this. So it goes to these two. And then, just for consistency, we're going to do the cyan one as well, even though it's 0. Cyan southwest is this. If I didn't explain it before, what we were doing is taking these values and removing all the decimals, basically rounding down, as it says here. So in this case we get 15, 0 and 15. Modulo 5, we get 0, 0, 0. And then adding the previous one we got 1. And then all of these are going to be 1. Because that was the previous, the Y value of the previous press, modulo, and then modulate by 5. Previous press from the last stage for the first one. Last of stage 2 was 1, so we get 0 plus 1, which is 1. And then we get 0 plus 1, 0 plus 1, basically. Because we're adding the Y value of the previous press, but since all of them were 0, and we're adding 1 to all of them, that makes sense. Okay, so now we have these values. These are the values for these first 3. And now, let's find the final button. So, only seeing the button flashes in the stage colour the highest F value, so it's of their initial and final values. So the highest is red, 26. For its initial value was 33. And this is going to be our X value for now. So, 59. And we're going to be adding... Our target button is currently the button of this colour. So the target button is currently red, we'll get back to that. Add 2 times the sum of the previous Y values from all stages. So that's why I said to keep hold of them. So double the Y values from all the previous ones. So that will be 3 and 4. 1, 4 and 1. And then 1, 1, 1. We're going to take this value, take the number of strokes in the bomb at the time the previous button was pressed and divided by 5. So in this case, none. Then add 2. We're going to multiply this whole thing by 2. Multiply X by the result and round down in case you have the decimal here. And then using the table under, it says obtaining here, but it is this segment. This will be corrected. Using the table under determining press values section and exponentiate X instead. So let's take this value and see what we get. We get 182, as we can see here. And we're now going to find the value of red northwest, which is this, which is the segment it asks us to get it from. We take this value and we raise this number to the power of it this time, and we get, and it says round down, I think. Yeah, round down is our final X value. So our final X value is 6531. And now we're going to find our target button. It's currently red, but it might change, given what this shape looks like. So, the buttons from north clockwise are red, green, no. But if it was red, green, blue, cyan, magenta, yellow, then you'd not know how to do anything for this. The northwest button is yellow, no. Red directionally opposite cyan, that would be like across the shape here, so no. Yellow and green are separated by one button, no. Separated by two buttons. Blue and magenta are separated by one button, they're separated by no buttons. Red is in the top of the module, yes. So we're going to go to the next colour in this sequence, so red becomes yellow. Blue is in the bottom half, no. Starting from red, blue is further clockwise than green, no. Blue is less clockwise than green. Blue is further clockwise than green, yeah, that's false. So for cyan, the yellow button is further clockwise than the magenta button, no. Yellow is earlier than magenta, not after it. So our final press is hopefully Y at something, yellow at something. Wait, actually, before we do that, this is our current button, but we now have to take our X value and go clockwise that many buttons to get our final button. Unless the first condition in this applied, then you skip this step as well. To help out here, just take this modulo 6 to count around that many times. So we're going to be counting 3 from yellow, clockwise. So it's green actually, 1, 2, 3. The colour is actually green after this modification. Take the to root x of x and make it your y value. The root of x, which is this, gives us 15, which then gives us 6. This is our y value. At the y button, at the y value obtained from the previous press is 1, so we get 7. If the target button is north, northeast, or southwest, no, but we'd add 1. If it's northeast, south, or southwest, yes, green. It's south, so we subtract 1, so we get 6. Press the button when the sum of the digits is exactly this value. So these ones are going to be modulo, this one is going to be exactly. So hopefully if we've done this right, we should get red on 1, cyan on 1, which could be also 11 or 6, I think. It's mod 5, so mod 5, right? Yeah, mod 5, so 1 is also 6. Then 1 or 6, so let's go for 6 again. And then green when it's exactly sums to 6. Then hopefully we get a module. That was a long module, so sorry if I didn't explain some stuff. I'll quickly do a quick brief run through again. Initial values. Take the first character of the serial number, convert from base 86 to decimal, and add each of the values given by cross-referencing the colour and where it is in the shape, in the snowflake. Follow these rules to get flash values, which are used here. The flash values is the values after these rules, which is then used to order the presses for these stages. After you decided what bunch you're pressing, you take the sum of the flash values or the initial values if they didn't flash. This would be called x, and then divide x by the cross reference of the colour and its position of the button you're pressing. Take modulo 5 and then add the previous y value. Okay, the previous value you got, so here this was M1, but since this was 3, we added 1 and 3 and we get 4. Hopefully that makes sense. And then we press the button when the sum of the last 2 digits of the timer, modulo 5, is equal to our y value, apart from the final button, where we go through these rules and these rules to find our button and our final value, and we press it on exactly that sum, not modulo sum. Because of course, some of these values, as we saw here, mod 5 can't get 6, so that has to be the sum exactly. That's a way to remember that. And some extra things down here. The module will not submit unless you press buttons an appropriate amount of times. So first stage is 2, second stage is 3, last stage is 4. If your submission is wrong in any way, the stage counter will start flashing different letters to note the state of the presses. Stage number will be the break between the flashes. We start flashing different layers to denote the states of presses. We get the stage number, and then sorry if I'm explaining this wrong. Then we get G or M when the correct button was pressed at the right time. So meaning you got that one right. Correct button pressed at the wrong time means you pressed the right button at the wrong, but the timing was wrong, and then everything was wrong. Or the button was wrong, but the timing might have been right, if it was that button. If any incorrect stages were done, wrong time, wrong button, the module strikes, and the module will repeat the flashes. However, the flashes will not regenerate, so they'll be the same. Colorblind mode is useful. Hovering over the button will reveal the letter on the stage counter, RYGCBM, like here. And a little extra bit that if you press only buttons, they will play this song, just so you get bored during solving. So that was Time and Songs. Hopefully it makes sense. Sorry if I haven't explained it very well. Hopefully the process of me doing it at least helped a little bit. And I'll see you guys in the next tutorial. I'll see you later.